Welcome to the 9th video in the series of videos on factorization. This is the 6th video on problem sets, and this one would be the last one in this chapter. Here we are going to look into how to solve or how to find out the factors for an algebraic expression when it is represented in a very generic form. So let's take the first problem and try to see how to do this. So if you have, let's say, x squared plus 5x plus 6, let's assume that this can be written in the form x plus p into x plus q, and this amounts to x squared plus p plus q are both your terms into x plus pq. So you have p into x and q into x. So let me expand it properly. X into x and x into q plus p into x plus pq. So the sum of terms is your 5. So I can say, hey, your p plus q, your sum of terms is 5 and your product of terms is 6. So find p and q. So obviously p would be 3 and q would be 2. This implies that you can write x squared plus 5x plus 6 is x plus 3 into x plus 2. So that's how you solve the problem. The next one, I urge you to pause the video and try to do this. Try to do the second problem by yourself. So in this problem, the sum of terms are 5 and product of term is minus 6. That will give you p as 6 and q as minus 1. So you can split the middle term as follows: plus 6x minus 6, or you can say x into x plus 6 minus 1 into x plus 6. You can take x plus 6 as a common term. This would be x plus 6 into x minus 1. So that's how you can solve the problem. The next problem is a little bit different in a sense that there is a coefficient for x squared. So when you hit a coefficient for x squared, 3x squared minus 11x minus 4, what you got to do is you got to find p and q such that p plus q is minus 11, so this thing stays, and your pq would be product of 3 into minus 4, 3 into minus 4, so that would be minus 12. So if you look at the previous problem, here the coefficient of x squared was 1, so 1 into minus 6 is minus 6. So it's a special case of doing like that, doing like this, where you say pq is product of the terms are nothing but a into the constant term, right? So here pq is 3 into minus 4. So which implies your p would be equal to minus 12, and q would be equal to 1. So you can write this as hey, this is 3x squared plus minus 12x plus x minus 4. So this is your p and this is your q, which is 1. You can take common 3x outside. This would be x minus 4 plus 1 into x minus 4. You can take x minus 4 outside. That will give 3x plus 1 and x minus 4. So that's how you can solve this problem. The key is to remember that your product pq, the terms, would be 3 into minus 4. You have to multiply this suffix for x squared as well. So with this idea, I urge you to pause this video and try to do the fourth problem. One good way to approach this problem would be to get this coefficient of x squared as plus. So what you can do is you can take minus 1 outside and say, hey, this is 4x squared plus 12x minus 7 equal minus 7. And so all the signs have got flipped here. Now you can approach the idea of your sum of the terms are 12 and your product of the terms is 4 into minus 7. That's minus 28. If you try to solve this, or if you try to guess what the values of P and Q could be, so your P could be 14 and Q could be minus 2. So we can split this term as 4x squared plus 14x minus, or rather minus 2x plus 14x, or it's fine, 14x minus 2x minus 7. The next step would be, you can take some common factors here. Between this and this, you can take 2x, and this will be 2x plus 7 minus 1, 2x plus 7. You can say this is equal to minus 1. You can take inside the bracket 2x plus 7 outside, and the other term would be 2x minus 1. So that would be your answer. That's how you can find the factors. So I hope you enjoy this video, and I wish you good luck to solve all your exercise problems. And remember, you become a master of factorization by practicing and practicing and practicing. And once you have this in your head, I think everything will flow like just a free flowing stream or something. It'll just click you. Okay, so keep trying and wish you good luck. Bye bye.